For this video, we're going to be discussing simplifying radicals. So let's start by defining what is a radical. A radical is simply the root of a number. For example, the square root of 4 equals 2. This square root here, that's a radical. Okay, radical is just a symbol for a square root. Okay, it doesn't have to be a square root. It could be, for example, the cubed root of 8, which is also 2 because 2 times 2 times 2 equals 8. All right, we're going to be working mostly with square roots, though. And so just know that a radical is simply the square root symbol. So numbers whose square root is an integer are called perfect squares. So, for example, 4 is a perfect square because the square root of 4 is 2. And for numbers and monomials that are not perfect squares, we can simplify the radical. For example, the square root of, say, 27, I'm going to show you, we can write as the 3 times the square root of 3. All right, well, this is the main focus of this video, is going to be showing that how we can reduce this square root of 27 into 3 times the square root of 3. And a radical is in its simplest form when none of the numbers underneath the radical are perfect squares. For example, if I look at this example I just showed you, 3 times the square root of 3, the square root of 3 is not a perfect square, so it can't be simplified anymore. It stays underneath here. So let's figure out how we're going to do this. Let's look at two different examples and how they relate to each other. Right here I've got the square root of 169. Well, 169 is a perfect square, so the square root of 169 is just 13. Okay? Now there is no radical bar anymore, so this is done. All right? This is as simplified as it goes. But 32, on the other hand, that's not a perfect square. If I was to, example, get out a calculator, and if I was to do the square root of 32, I get 5.656854. Not exactly a perfect square. So, let's go ahead and show how we can simplify this. If I look at 32, I can think, are there any factors of 32, any numbers that go into 32 that are perfect squares? And if I think about it, the biggest one is 16. And 32, that's 16 times 2. Well, one of the properties of radicals says that if I'm doing multiplying like this, I can say square root of 16 times 2 is the same thing as the square root of 16 times the square root of 2. All right, I can separate these out. Well, square root of 16, we know that's 4. Square root of 2 is not a perfect square, so that's as simplified as it goes. And I get that answer right there, 4 times the square root of 2. This is the most simplified version of this radical right here. And I can show you using my calculator here how that's true. If I take the square root of 2 and I multiply it by 4, I get the same thing, 5.65684, as if I take the square root of 32. All right? So, our procedure to simplify a radical is to factor out any perfect squares from the number, separate the perfect squares and non-perfect squares into their own separate radicals, and then just simplify the perfect squares. Let me show you another example. If I asked you to do, for example, the square root of 50, well, you know 50 is not a perfect square, but you know that 25 is a perfect square. Be careful to keep our radical here. So I know that 50, that's 25 times 2, so I can say, well, that's the same thing as the square root of 25 times the square root of 2. Square root of 25 is 5. Square root of 2 is not a perfect square, and it doesn't reduce. So 5 times the square root of 2. All right, so let's do an example. I would like you to try to simplify the square root of 150, and after you've got it done, I will show you how. So now that you've tried this one, let's go over it. Square root of 450. Well, what's the biggest perfect square that goes into here? Well, I can tell you that the 450, that's the same thing as 225 times 2. And 225, that's 15 times 15. So 225 is a perfect square. So I can separate these out into square root of 225 times the square root of 2. Square root of 225 is 15. So I have 15 times square root of 2. But let's say you didn't know that one. Let's say you didn't know that 225 was a perfect square. There's another way we could think about this. Another way we could do this. How about we know that 450 is a multiple of 25. All right? We know that 450, that's 25 times, I'm not sure exactly. Let's bring out the calculator again. 450 divided by 25. Okay, 18. So that's 450, that's 25 times 18. All right? Well, 18, do we know of any perfect squares that go into 18? We do. That's square root of 25 times 9. 9's a perfect square times 18. All right? Or not times 18. Times 2. Okay? So hopefully you see that 9 is a perfect square. It goes into 18. Now, these two are both perfect squares. This one is not. So I can go over here. I can say, well, that's the square root of 25 times 9 times the square root of 2. Nice thing about radicals, I can do, well, that's the square root of 25 times the square root of 9 times the square root of 2. Square root of 25 is 5. Square root of 9 is 3. Square root of 2 doesn't reduce. And 5 times 3 is 15 times the square root of 2. So if you can't think of the biggest perfect square that goes into a number, you can at least think of one perfect square, split it out, then think of another perfect square that comes out of what's left, split that out, and just keep going until what you're left with doesn't have any perfect square factors. Either way, we should still get the same answer of 15 times the square root of 2. Now, it doesn't just have to be numbers, whole numbers, that are perfect squares. We can have variables with exponents that are also perfect squares. For example, any variable with an even exponent, underline, double underline, so you remember this. Any variable with an even exponent is a perfect square. So to find the square root of an exponent, you simply divide that power by 2. Meaning the square root of 8, or the square root of x to the 8, is simply x to the 4th. Because if we think back to our power rules, x to the 4th times x to the 4th, well, that's x to the 4 plus 4, which is x to the 8th. But we could also think of this as x to the 4th squared, which is x to the 4th times 2, which is, once again, x to the 8 power. All right, so just know that anytime you have an even exponent on a variable, that is a perfect square, and to figure out the square root, we just divide by 2. So let's take a look at an example with this. We want to simplify m to the 15th power. So m to the 15th. 15 is not an even number, so this is not a perfect square. But m to the 15th, I can think of that as m to the 14th power times m, right? Because m to the 14th times m is m to the 14. Remember, this is m to the first, so m to the 14 plus 1 equals m to the 15th. So I can split my m to the 15th into m to the 14th times m. Now this is something that you're going to be doing a lot while we're simplifying radicals, is any odd power can be split into an even power times that exponent to, or that variable to the first. Okay? So now for m to the 14th, that's a perfect square. So I'm going to set up two radicals here. This is my perfect square radical. This is my non-perfect square radical. M to the 14th is a perfect square. It goes in here. M is not, so it stays here. As I said a second ago, to do the square root of the perfect square exponents, we just divide by 2. That's m to the 7th. The square root of m does not reduce, so my answer is m to the 7th times the square root of m. Alright, so all we did is we split our odd exponent into an even and an odd. Took the square root of my perfect square even exponent, which just means we divide our exponent by 2, and left the non-perfect squares in the radical to get m to the 7th times the square root of m. Alright, so now we can do this even if we have more than one variable. So, we're going to simplify the square root of a to the 9th times b to the 14th. So let's think about this. A to the 9th is not a perfect square, but a to the 9th equals a to the 8th times a. So I can split this into a to the 8th times a. B to the 14th is a perfect square, so I'm not going to do anything with it. I'm just going to leave it alone for now. It's an even power, so it's a perfect square. So now that I've separated these out into perfect square, non-perfect square, I'm going to set up two radicals that are going to be multiplied together. These are my perfect squares. These are not. A to the 8th is a perfect square, so it goes in here. B to the 14th is also a perfect square, so it goes in here. And a is not, so it goes by itself in here. Now in this radical, we can think of that as the square root of a to the 8th times the square root of b to the 14th times the square root of a. Remember, to take the square root of a power, we just divide it by 2. So the square root of a to the 8th is a to the 4th. 8 divided by 2 is 4. Square root of b to the 14th is b to the 7th, because 14 divided by 2 is 7. And the square root of a stays in it there by itself. I have no more simplifying to do, so that is my answer. A to the 4th, b to the 7th times the square root of a. All we did is split apart our perfect squares from our non-perfect squares, simplify the perfect squares. So let's put all of this together in example 4. I'd like you to try example 4, and then we'll go over it together. So now that you've tried example 4, let's see how you did. We're going to take each one of these numbers, 288, x to the 13th, and y to the 5th. We're going to split them apart into our perfect squares and non-perfect squares. So, 288, you could have done a few ways. There are several perfect squares that go into 288, but I'm going to go with the biggest one. 288 is 144 times 2. 144 is 12 times 12, so that is a perfect square. X to the 13th, I can split into x to the 12th times x. Y to the 5th, I can split into y to the 4th times y. Alright, so I have this is a perfect square, this is a perfect square, and this is a perfect square. So now I'm going to set up my two radicals. Perfect squares, non-perfect squares. So 144 goes here. So does x to the 12th. So does y to the 4th. And over in this one, my non-perfect squares, 2x and y. And now I'm just going to simplify this radical over here. The square root of 144 is 12. X to the 12th, the square root of that, 12 divided by 2 is 6, so that's x to the 6th. Y to the 4th, 4 divided by 2 is 2, so that's y squared. This can't be simplified, so square root of 2x, y. So all I did, separate each one of these numbers into a perfect square factor and a non-perfect square factor. Perfect square factor, non-perfect square. Perfect square, non-perfect square. Sorted them into two separate radicals. Here are my perfect squares. Here are the non-perfect squares. And I simplified my perfect squares and left the other ones alone. So your try-it problem for tonight is simply to simplify the square root of 18b to the 7th c to the 6th.